All right, guys, please excuse the fact that I am on the floor of my classroom. It's the only place I could get enough light without there being really, really bad glare on the notes. So we talked about speed already, and now we're going to talk about acceleration. So acceleration is caused by a change in speed or direction or both. So like speed would be like, if there was a change in speed, it would be like you're sitting at the start line and all of a sudden you pressed your accelerator. So on my notes, I have like you start a drag race. So that's a definite change in speed, right? The light turns green and starts at red, turns yellow, turns green, and you press on the gas pedal and go. A change in direction would be like you turn a corner. Or both would be like if you're getting on or off the interstate, like an interstate ramp. So like when you get off the interstate ramp, it's really curved. And so you either speed up or slow down as you go down that curved ramp. So you're changing direction and you're changing speed. So our formula for acceleration is pretty easy. Acceleration is equal to, well, before we get started with that, acceleration A. This A stands for acceleration. This little hat tells me that it's a vector. So this A stands for acceleration. And the textbook definition for acceleration is the rate of change of velocity. So the definition itself tells you what the formula is. So it's the rate of change of velocity. So this up here, the delta, remember, always means change. So delta V is a change in velocity. So this is going to stand for our change in velocity. All right, but what is our change in velocity? So our change in velocity is going to be our final velocity minus our initial velocity. And those are vectors. And there's different units we can use for this. There's a few different units. We can either use meters per second or kilometers per hour. That's going to be one of the first things you need to check for when you're working a problem, is you're going to want to make sure that what they gave you is what they're looking for in the answer. So if they give you meters per second in the problem, make sure you have your answer in meters per second. All right, the bottom, or that T, represents time. So our T represents a change in time. And that can be in seconds or hours. Sometimes it's even in minutes. If it's in minutes, though, we want to make sure we convert to seconds or hours first, because our velocity is either going to be in seconds per hour. We don't have a velocity unit that comes in something per minutes. So if we have our time in minutes, we're going to have to convert to seconds or hours before we start the problem. So time is a scalar. It's not a vector, so I'm not going to put a hat on it. So it's the final time minus the initial time. So when some people write out the formula for acceleration, they're going to write it a little bit differently than what I have up here. When some people write out that formula for acceleration, they are going to write out that acceleration is equal to the velocity final minus the initial velocity, those are both vectors, over the final time minus the initial time. So this is what I would remember if I was going to remember a formula for acceleration. All right, units in the very middle. This is important. What units can I give acceleration in? I can give units, the units I'd be looking for the most, and what most problems are looking for is meters per second squared or meters per second squared. That is what my answer is 9 times out of 10 going to be in. So let's try and apply all this to a math problem and see how we do. So it says, find the average acceleration of a bus that reaches top speed of 14.2 meters per second from rest in 22.8 seconds. So the first thing I want to do is write down all of my variables, what I'm looking for. So I'm looking for a velocity final, a velocity initial, a final time, and an initial time. So it says the top speed is 14.2 meters per second. So that's my final velocity right here. So I'm going to write that down here as 14.2 meters per second. And it said it comes from rest. So if it's from rest, its initial velocity would be 0 meters per second. Our final time is 22.8 seconds. So it happens in 22.8 seconds. If it comes from rest, it's not anywhere right now, so that initial time is going to be 0 seconds. So now I'm going to plug in this information into my formula for acceleration up here, and I'm going to see what I get for an answer. So my acceleration vector is equal to my final velocity, 14.2 meters per second, minus my initial velocity, 0 meters per second, all divided by my final time, 22.8 seconds, minus my initial time, 0 seconds. All right, I'm going to get that my acceleration is equal to 0.6228 meters per second squared. So my answer would be the acceleration, I'm just going to abbreviate, of the bus is 0.623 meters per second squared. But I can't just stop there because I said acceleration was a vector. It could happen with a change of speed or a change of direction, but it's always a vector, and vectors always need a direction to go with them. So I'm just going to put, since I don't know what direction it's going in, I'm going to put that its motion is forward, because we know it's going forward. It's going from rest to speed. So this down here is my final answer. All right, so let's go over here to these true or false questions. I'm trying to make them to where they don't have a glare. All right, acceleration occurs when a bicycle moves consistently in a straight line. So that's going to be false, because I don't have a change in speed, and I don't have a change in direction. All right, the second one says a raft moves side to side as it floats down the rapid. So I don't have a change in speed, but I do have a change in direction, so it's going to be true. I have a change in direction, and that change in direction is side to side. So that's what makes that true. All right, the last one says a car pulls into a parking spot. Is that acceleration? And it sure is, that's true. So the first thing I'm gonna look for is a change in speed. And if you pull into a parking spot, let's hope you're gonna press the brakes. If not, you're gonna hit the car in front of you. Also, when you pull into a parking spot, you are going to change directions. You either have to turn left or right to get into that parking spot. If you're going to parallel park, you have to put the car in reverse. So no matter how you park a car, you're going to have a change in speed and a change in direction. So that's an example where acceleration has both speed and direction change. And that is the end of today's Doodle Notes. So you should be completely done with your notes for today.